In the field of unmanned aerial vehicle research, the design and optimization of swarm formation is of great significance. The research team proposed a self-organized formation swarm model with a constrained coordination mechanism, which designs a global information-based formation rule to flexibly maintain the formation, and introduces a new obstacle avoidance rule to prevent deadlocks. The research team constructs a forest-like obstacle environment indoors, conducts experiments using 7 quadrotors, and tracks the positional status of the UAVs through NOKOV motion capture system, which verifies the effectiveness of the SOF swarm model in real-world environment deployment, and provides a new solution to the problem of multiple UAVs flying in formation and sustaining the formation in dense environments. The research team also proposes another distributed self-organizing Reynolds swarm model based on the behavioral characteristics of biological swarms, which uses the most straightforward potential functions to design the interaction protocol between UAVs within the swarm when only using the local UAV velocity and relative position information for interaction, enabling the whole swarm to be able to navigate safely and sequentially in the obstacle-strewn environment. Based on NOKOV motion capture system, the SOR swarm model is validated using 5 quadrotor UAVs in a real indoor environment, and a safe, orderly, and compact self-organized UAV swarm flight in a dense obstacle environment is successfully achieved.